Howdy folks, it is Mr. Ensminger here with one of my favorite little projects we're going to do. This is the bounce counter, and it introduces an extremely important tool, the timer. So far, your programs have been action driven by the user. You click a button, you type stuff in the text box. Here, the timer tool is going to show you how to do things like animation, because the program is going to run code on its own. So first what I'm going to do, I'm going to get my form set up. I'm going to call this bounce counter, and I'm going to give this background image today. Let's say I'll go to my resources folder, sample graphics, background. Let's go to, I don't know, marbles, and let's go with that one. Obviously, you are welcome to pick whatever your little heart desires. That's just what I'm choosing. All right, next, I'm going to make this full screen. All right, now to do that, I'm going to do two things. One, I'm going to go to the very bottom of my properties. Window state right now is normal. If I open that up, my choices are normal, minimized, or maximized. I select maximized. What happens then is I run this, and shockingly enough, my window will start full screen. Now, the other thing I want to do with that, I want to know what are the dimensions of my screen. Now, here's where we got to be a little careful. You got to pay close attention. My screen might not be the same size as your screen. So I'm going to get my numbers, you get your numbers. I'm going to minimize Visual Basic for a second. I'm going to right click on my desktop. I'm going to go to Display Settings. If I scroll down a little bit, my display is 1920 by 1080. Okay? Again, that might not be your display, so check it before you just assume that that's the case. So 1920 by 1080. What that means is I'm going to go to my properties, I'm going to go to size, and I'm going to put in 1920 by 1080. Now the reason I'm doing that is when I run the program, sure, it's maximized, but in my design, it was still this little window. So to get it precisely the way I want it, I'm going to match up, maximize with what the actual values would be. Okay. Now, in here, you can now scroll up and down to see the entire form. Okay. Unfortunately, there's not a great way to zoom in or out of this. It's just, you can see what you can see. Fortunately for this program, we don't have to do a whole lot. What I'm going to do first is I'm going to make it in the toolbox. I'm going to go to label. So double click label, and I'm going to do some very specific things with it. I'm going to put in the top left corner, I am going to go to auto size false, of course. I'm going to go to text alignment center, of course. I'm going to make this a specific size. For my size, I'm going to go 100 by 100, a nice perfect square. 100 by 100. All right. The text, I'm going to make the number 0. Bounce counter. It's going to bounce and count. Shocking. Now I'm going to change the font, the foreground color, the background color. Let's make it sort of match up. I'll do a little bit bigger. I don't want to go too big because I don't want to have a 2 or 3 digit number kind of mess up there. My background color, let's make this sort of, I don't know, dark turquoise. Yeah, it kind of matches dark turquoise. As always, feel free to pick whatever you feel like you should pick. So you've got a background image, you've got a label box, certain color, certain font. Yay. We are about to enter a fun little journey together. This is where Visual Basic starts getting really fun, because now you can start animating things, which means we are a few steps away from being able to make a game. In fact, you could probably even classify this in some ways as a game. here's what I'm going to do. I need to make what's called a timer. A timer is a tool which will allow you to do events based off of a certain interval. Now, when you look here at the common controls, there is no T for timer, unfortunately. So for the first time, we need to go to all Windows forms and scroll down to T for timer, or your other choice is stick with common controls. Right above that, there's search. If I type timer, hey, look, there it is. Double click, and it'll make a timer. And it makes a timer in somewhere we call the component tray. The component tray is this little area down here, part of your project, but not on your form. You can't see this thing. It's behind the scenes. The properties of a timer, there are very few of them. Enabled. It starts as false. The timer's not on. We want it to be on when we run the program. So turn it on. You can turn it on and off in the code, but we want it on, we want it on in the program. The other one we're going to modify is interval. If you look down at the bottom here, it says the frequency of events in milliseconds. Millisecond, the prefix milli, 1,000. So if I do 100, that is 100 1,000ths of a second. That's a tenth of a second. Okay, 1 whole second will be 1,000. Because I'm doing animation, I'm sure many of you know FPS, frames per second. Okay, usually the faster, the better your eye's going to keep up with it. Something that is animated every 1 second, it is really choppy. I mean, that'd be like me holding my hand here, and that's here, and that's here. It's really choppy. The fastest I'm going to go is 1. You can't do decimal. You obviously can't do negative. 1 is the fastest I can go. Every 1/1000th of a second, we're going to do a certain bit of code. So enable true, interval 1, which is, to be honest, the most common settings you're going to use when you make a timer anytime we do animation. Enable true, interval 1. Okay. We are all set up and ready to code now. Here's what I'm going to do. I am double clicking first on the form itself because I need to set some stuff up. There's a decent amount of code that we're about to do. So prepare yourselves. I'm going to go to the top into my declaration section. I am going to dim. I'm going to dim dx as integer, dim dy as integer. All right, let's talk math, boys and girls. Where have you seen dx dy? Slope. When we're animating something, it is a change on a two-dimensional plane, left or right, up or down. All right. Now, let me just get out my handy-dandy whiteboard here, that being Microsoft Paint. So let's say I have this rectangle, square. It's measured from the top left corner, right? And then we call that the left, comma, the top. In Visual Basic, the top left corner of something is the property left and top. You can think of it as the X and Y, but it's measured from the top left corner, not the middle. Remember that the screen, here's my screen, my form, the screen is measured also from that coordinate. That's the origin. That was mentioned in one of our previous videos. The origin of your screen is not in the middle. It's in the top left. Everything in Visual Basic is measured from the top left corner. Why? Well, watch this. If I want to draw something, how do I draw it? There's my little cursor. Click and drag. It's anchored in the top left. I change the width and height. So when you do something in Windows, you anchor it in the top left corner where you first click your mouse. So how do I animate this thing? Well, dx is going to be how far do you want it to go this way? If you want to go right, you would make dx positive. If you want it to go down, y is reversed. 0, 0 is in the top left corner. So positive y is down the screen. Now remember, this edge here, this is 1920. Remember that from our measurement? I know that's not really a good looking 19, but it is. And then down here is 1080. So how do you get this to go in an angle? Well, that's where slope comes in. That angle is going to have a dy dx. It's the rise over the run. I mean, we're going back to pre-algebra with this stuff. That stuff all matters when you do animation and you do computer programming. So yes, the stuff you learned actually comes into play. Isn't that crazy? So, enough sass. Let me show you how this works. So we're going to dim those two variables. When you dim the variables, when you declare them, they start off as 0. There's nothing there. That means it's not moving. I don't want that. I want to say dx starts off as some number. Let's say 5. And dy would be the same number. Because I'm doing the same change in x, the same change in y, the slope is 1, 5 over 5, which means it's a 45-degree angle. Let that sink in for a second. For those of you in pre-calc and above, that makes perfect sense. If that doesn't make sense yet, think about a line that has a slope of 1 at just 45 degrees. The difference is, in algebra, that line would go up from left to right. On a computer, because the origin is the top left corner, it's going to go down to the right. So we start off, we declare those variables. Start your dx, dy values here in form load. The start of the program. Now we need the timer. So I'm going to go my drop down, timer, and then there's really only two choices here, and you want tick. This sub will run with each interval of your timer. In other words, this code is going to happen for us every 1 millisecond. That's a lot. It's going to go even faster than that. So how do you animate? To animate an object, we add or subtract a dx dy from its left top coordinate. Left is x, top is y. So watch this. Label 1 dot left equals label 1 dot left plus dx. Label 1 dot top equals label 1 dot top plus dy. Those two simple little lines of code will animate your label box. Now, 5 refers to 5 pixels. Every 1 millisecond is going to move 5 pixels. And I should also say, it's not, when I say 1 millisecond, it's not exactly just because of the processing speed of the computer, but it's all we have. Like, 1's as fast as it's going to go. It's perfect. I'm going to try and run the program. I don't know if the video capture is going to keep up with the animation. We'll see. You can try it. You can probably see quicker than I can. But I'm going to run this, and what you should maybe see is that's going to move down the screen. Look at that little thing. Isn't that adorable? It's kind of slow. A little choppy. Maybe yours isn't. Maybe you didn't put a background image on. Well, there's a little thing that we need to tweak. I'm going to go back to my design. Again, my timer, here's my properties. I think I closed by accident. Properties. Intervals as fast as it's going to go. Making the dx bigger is just going to make it choppy. Now you can try it, but it'll make it choppy. What I need to change is I need the computer to devote more memory to my animation. I have the forms properties up. There's a property on your form called double buffered. It's false right now. I'm going to turn it to true. That one subtle change makes it 10 times smoother. When you do animation, make certain you turn on double buffered. This is going to vary completely based off of how fast your computer is. Do you have a graphics card? I'm using a school computer with obviously no graphics card. So if you're doing this on your high-powered PC at home, maybe that looked perfectly fine. And it's also mostly because of the background image. If I got the background image off, it's much smoother because the computer's devoting less processing power, less graphics RAM to animation. So turn double buffered to true to get this to work. I shouldn't say get it to work. It'll still work, it just won't work as well. So I'm going to put that in a little note here. Don't forget to turn on the forms double buffered property. All right, now what comes next? Well, it's called bounce counter for a reason, because right now it's just going to go off the screen. It's just going to keep on going. We need to bounce. All right, so let's bounce. To detect collision of the label on the bottom wall. It's an if statement. If label one dot, so picture this. It's going from top to bottom. It's going to hit the bottom of the form, which is the value 1080. The label's bottom will hit first. Label one dot bottom is greater than 1080. All right, now I want you to be a little bit wary of this. Never say equals. When detecting collision, always use less than or greater than, not equals. Here's why. We're counting by fives. This is an exact number, 1080. So let's say you're animating it, and right now the animation is at 1077. So it's really close to that edge. The next frame of animation is going to be 1077 plus 5, which is 1082. It skips right over it. So if you said equals, whoop, too bad. So you want to say greater than, so it's saying any time it goes equal to or past it, it's going to rebound. So how do you rebound? Well, the angle of incidence equals the angle of reflection. Basic middle school science. When it hits at a 45-degree angle, it needs to rebound at a 45-degree angle. What's changing? It's still going left to right. So dx does not change. dy, however, goes in reverse. dy equals -5. It went from positive to negative. Let's try it. Wait for it. Bounce. Oops. 0. Right? Not 0. dx just doesn't change. dx is still going to be 5. If you do 0, it's going to go whoop straight up. That's clearly a weird bounce. So now let's look at it. Watch what happens. Come on down. Boop. And by the way, if it seems like it's going below, it's because you're forgetting that my taskbar is there. So it's still going like inside my taskbar, but whatever. We can hide the taskbar. I'm just not worried about that. So now it goes off the screen to the right. So we got to keep going. Now the other thing that's part of this is it's called bounce counter. So what I'm going to do is I'm going to incorporate that count into my label box. That's why I have 0 on it. When I come on back up top here, I'm going to say dim count as integer. Dim count is integer. Starts at 0. So in here, when I hit the wall, count equals count plus 1. Label 1.text equals count. So every time it hits the wall, I'm going to add that code. All right. So what comes next? What comes next is if label 1.write, and it always fights you on this. Come on. There we go. Greater than 1920. Right. If you have problems getting that to say right, hit escape to cancel the autocomplete. I don't know why, it just always, pain in the butt. dx equals -5. dy, well, if it hits the right side, what do you want to do? You want to keep going up. Okay. Count equals count plus 1. Label 1 text equals count. We're going to finish the last two, but maybe you're getting a sense that something might be a little off here. Just hold that thought. So this is the collision with the right edge. Next would be, in order, collision with the top edge. This is kind of like a screensaver. I mean, you've probably seen the videos of people like hyping up DVD, that little logo going right in the corner of this, and like, this is kind of what we're doing here. If label 1.top is less than 0, so the top of the screen, 0. Left of the screen, 0. Those are the edges, 0, 0. 1920 across, 1080 down, 0, 0 in the top. We switch the signs because it's the value that would go negative. It's less than. The other two greater than. So here we go less than 0. Did it go off the top edge? dx equals, well, we still want to go left, but now dy rebounds back to 5. Count equals count plus 1. Label 1 text equals count. And then finally, collision with the bottom edge. Or not the bottom edge, you guys are thinking top and bottom. Collision with the left edge. If label 1.left is less than 0, then dx positive, dy negative, positive? That's strange. I wonder why I'm kind of confused on what order, or what direction I should say, these bounces go in. Some of them are slightly ambiguous. They sort of need to follow the way it was going. Keep that in mind as I run the program. There's some tweaks we're going to have to make here. Let's watch it bounce. Good. Good, good. Uh-oh, it's going to hit the bottom again. But that means it's going to bounce the other way because we told it to go a specific direction. Oh no, it was working so well and now it's just stuck. Back and forth. Very exciting. So where was our mistake? Our mistake is our logic. We gave specific numbers when it's not really specific numbers. How do we know what direction positive or negative to go in? Because we don't know in which direction it came from in the bounce. So here's what you need to do. Don't put 5 or -5 here. If it hits the bottom, it goes in the same direction it was going. dx equals dx. So in other words, the dx did not change. If it's negative, it stays negative. If it's positive, it stays positive. This changed, though. Putting a negative sign in front of a number switches the sign, switches the direction. That's the key. Don't put real specific numbers there. Put the variables. dx doesn't change, dy does, down here. All right, so let's kind of work this back to the way it was. Right side, if it hits the right side, what should change? The dx should change direction, but the dy should not. When it hits the top side, what should change? The dx Well, if it hits the top side, it's going back down. So the dx stays the same. The dy changes. Finally, when it hits the left edge, the x changes. The y stays the same. Go back and look at the math. Excuse me. Bottom. Excuse me, hang on a sec. Need some water. Whew. Bottom. Y changes because it's a Y bounce. Right is an X bounce, so it's X. Bottom and top are Y coordinates. The left and right are X coordinates. Man, I'm talking too much here. So now our bounce should work flawlessly. Let's try. Yeah. I'm going to take a break. Bounce, bounce, bounce. Bounce. Bounce, bounce. Looks pretty good, doesn't it? So congratulations, you have made an adorable little screensaver type thing. Right, last thing I want to show you with this, we placed our label in the top left. So it's going to go in the same exact pattern every time you run the program. If you want to start with that at a random location, you can do that. Go up to form load. Start the label in a random location on your form. Be careful of being too close to the edges though. Okay, so if I'm going to do a label 1 dot left equals int rnd times 1920 to do a random location from 0 to 1920, the problem is what happens if it gets so close to the right side that it's hanging off the right side, it's going to get stuck there. So I don't want to go the whole way to the right side. But similarly, this is plus 0, so it's like right on the edge of the left side. So I'm going to tweak this a little bit. I'm going to say maybe, like 1700 plus 100. That way it stays away from the left side and the right side. Could I be more precise about that? Yes, of course, but whatever. Doesn't matter. Label 1 top equals int rnd. Again, I could do 1080, but you potentially could be too close to the top or the bottom. So, once again, we know that our square is 100 by 100, so let me back this off a little bit, maybe like 800 plus 100. That way, every time I run the program in the form load, when it first starts up, it's going to move that label to somewhere random. So now, like mine started over here, so now it's going to give you a different bounce pattern each time you run the program. It'll still be 45 degrees each time, but it'll start in a different location, which gives you a different path. Enjoy. Thanks for watching. Until next time.